This is Dr. VNSR Venkateswara Rao, working as a Associate Professor in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic on the electrochemical cells. These electrochemical cells based on the principle of the electrochemistry. So the branch of chemistry which deals with the chemical changes caused by the transformation of the electric current and production of the electrical energy due to the chemical changes is known as the electrochemistry. That means mainly the movement of the electrons is very important in the case of the electrochemistry. It is also takes place by the nothing but a redox reaction. Redox reaction means the reaction simultaneously takes place both oxidation and reduction reaction. Oxidation means loss of electrons. Reduction means gain of electrons. Electrochemistry deals with the study of the electrochemical processes and their applications mainly involved the conversion of electrical energy into chemical energy and the conversion of the chemical energy into electrical energy. So electrochemical cells. These electrochemical cells is also called as a galvanic cell, which is a device for converting the chemical energy into electrical energy by spontaneous redox reaction within the cell. That means the redox reaction takes place both oxidation and reduction in the respective electrodes. So that means at anode what happens, oxidation takes place. At cathode what happens, reduction takes place. By the combination of these two electrodes we get a complete cell, nothing but a net cell reaction. That net cell reaction is called as a redox reaction. These cells are called as electrochemical cells are voltaic cells. Why? Because this is invented by the voltaic and galvanic. So these cells are called as a voltaic and galvanic cell. And the best example for these electrochemical cells is the Dundigal cell. So mainly these electrochemical cells containing the two types of the electrodes. One is anode present on the left side, and second one is the cathode at right side. So at anode what happens, always takes place oxidation. Oxidation means loss of electrons. And what happens at right side, reduction takes place. Reduction means gain of electrons. So because of the loss of electrons on left side and gain of electron right side, the electrons flows from the left to right. Left to right. So what happens in left side, oxidation takes place, and what happens at right side, reduction takes place. Because of the loss of the electrons on left side and gain of the electrons on right side, finally the electron choose the movement from left to right. So that movement of the electrons are found out by the voltmeter. And another important parameter is these two solutions are separated by a salt bridge, and differently we taken in the different types of the electrolytic solutions in anion chamber and cation chamber. That means two different electrolytic solutions are separated by a semi-permeable membrane. So in the case of another important factor is the liquid junction potential, in which case liquid junction potential arises when two of cells are separated by a porous partition. Liquid junction potential arises when two of cells are separated by a porous partition. Liquid junction potential arises. Through the porous partitions, ions move in the opposite direction with the different velocities. These velocities are depends upon the charge on the ions. The charge on the ions. That may be either positive charge or negative charge. That means in the case of the HCl electrolyte, what happens? It dissociates into H plus and Cl minus. So H plus ions velocity is far greater than the Cl minus ions. Hence Cl minus accumulates at the junction, causing a charged double layer. And charged double layer possesses a certain potential is nothing but a liquid junction potential. That means because of the accumulation of the ions at a double layer, it causes some potential. That potential is nothing but a liquid junction potential. This liquid junction potential is represented by the LJP, short form, liquid junction potential is a nuisance and has to be eliminated. Because of the LJP eliminated by using the device is nothing but a salt bridge. Salt bridge. So this is the main purpose of the salt bridge used to avoid the liquid junction potential. So salt bridge show the like nothing but a diagram of the U-shaped curve. This U-shaped curve are applicable to separate out the two electrolytic solution present in the two different electrodes at anode and cathode. That means salt bridge is a U-shaped glass tube. U-shaped glass tube filled with the agar-agar gel and saturated with potassium chloride or potassium nitrate electrolyte solutions. So saturated means what is the condition for saturated? Saturated is nothing but a solubility product of the water is equal to ionic product. This is the condition for the saturated condition. So for this saturation condition, we choose a potassium chloride. Why you can choose a potassium chloride? Why? Because it dissociates to give a potassium plus and chloride minus ions. And the atomic number of the potassium is 19 and atomic number of the chloride is 17. The size difference between these two ions based on these atomic numbers is very, very small. That's why we choose the KCl is filled with the U tube and it is also maintained at a saturated condition. So one of the limb kept at analyte solution and another limb kept at a catholyte solution. That means analyte means at nearby anode, whereas catholyte means nearby cathode. In the cell representation, salt bridge always present in a vertical parallel lines. This is very, very important. This salt bridge is simply represented by parallel lines and electrolyte ions in the salt bridge process maintain a equal velocity. So this is the maintained conditions in case of the salt bridge. And the example for the electrochemical cells is nothing but a Daniell cell. So Daniell cell means we see the Daniell cell, what happens from left side we consider as a zinc sulfate solution and right side we consider as a copper sulfate solution. Both are two electrolytic solutions. In zinc sulfate solution we dipped a zinc plate. In copper sulfate solution dipped a copper plate. So according to the principle of the electrochemistry or electrochemical series, what happens at anode always takes place oxidation at anode and cathode what happens reduction takes place. By the process of oxidation and reduction, understand the electrons loss at one place and electrons gain at another place. Because of the loss and gain of the electrons and balancing these electrons moves from left to right. That means from anode to cathode, left to right. Anode to cathode, and the movement of the electrons is represented by voltmeter, and both are separated by a salt bridge. So why? Because these two different electrolytic solutions do not mix with each other, and to avoid the liquid junction potential, LGP, liquid junction potential, we use the salt bridge is the main purpose. And in the case of these two electrodes at anode, zinc electrode, oxidation takes place. That means loss of the two electrons by the zinc and get a zinc plus 2. And right side what happens, copper, those loss of the two electrons from the anode and received by the copper plus 2 and get a metallic copper. So representation of this Daniell cell, on left side what happens, zinc present in zinc sulfate, and right side what happens, copper present in copper sulfate, and both are separated by a salt bridge. So that is represented by parallel symbol. So this is very, very important for the representation of the Daniell cell, and the flow of electrons from one electrode to other causes the potential difference between the, which is called a EMF. EMF means electromotive force. Electromotive force. So under the electromotive force, the electrons are moved on the respective electrodes. So this Daniell cell is mainly made up of the two half cells. One is oxidation or anodic half cell, and other one is the reduction of the cathodic half cell. So that means two half cells containing the two half cell reactions and completed by a reduction and oxidation to get a redox reaction. So that is called a net cell reaction, and means it has cathode as a positive electrode and anode as a negative electrode. Always the oxidation takes place at anode and reduction takes place at cathode. The first half cells containing the zinc electrode dipped in the zinc sulfate solution and light solution, and the second half cell consists of a copper electrode cathode dipped in a copper sulfate electrolyte solution. That means the left side solution is called as a analyte solution and right side solution is called as a catholyte solutions. Or anode present on left side and cathode present on right side. So in this Daniel cell, what is the example for the anodic or analyte solution? Nothing but zinc electrode dipped in zinc sulfate solution. And what is the example for catholyte solution or cathodic copper dipped in a copper sulfate solution? That means both the half cells are connected externally by metallic conductor. That means why? Because used in metallic conductor having the facility to move the electrons from one side to other side. And conductor definition, the moment of the electrons flow through that substance. So we consider as a metallic conductor. Why? Because metals are good conductors of electricity. So what is the Daniel cell means that two electrolyte solutions are separated by internally by a salt bridge. Why? Because to avoid the liquid junction potential. To avoid liquid junction potential, the solutions can flow through to touch with each other. It provides electrical contact between the two solutions and elimination of liquid junction potential. That means the movement of electrons takes place from zinc to copper produces a current in the circuit. And what is the chemical reactions in Daniel cell? At anode, negative electrode always happens. The loss of electrons takes place. The loss of electrons is nothing but a de-electronation. So initially zinc can be considered as a solid material, and when it dissolved in the liquid solution, it will be aqueous solution. Because of the applied EMF, the zinc undergoes the oxidation, and finally it converts from zinc to zinc plus 2 with the loss of the 2 electrons, and charge is plus 2 charge. Because of the oxidation of the electrons takes place at anode, simultaneously the reduction takes place for the balancing of the chemical reaction. That will be takes place at cathode. That means those loss of the electrons will be received by the cathode. That cathode takes place the process nothing but a electronation reaction. That means reduction takes place. That means the charged copper get a 2 electrons to get a metallic copper. The overall cell reaction is nothing but a redox reaction. That means from zinc to zinc plus 2. What happens? Oxidation takes place. And copper plus 2 copper. What happens? Reduction takes place. That means by the combination of these oxidation and reduction reactions are called as redox reactions. That means according to the definition of the redox reaction, the reaction simultaneously takes place both oxidation and reduction reaction. So such type of the cell reactions mainly observed in the Daniel cell. That means finally you understand that the chemical energy converts to a electrical energy. Chemical energy converts to a electrical energy. So this is the one type of the electrochemical cell process occurred in the electrochemistry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.